Thanks a lot for tuning in. My name is Hans Eisermann, and on behalf of everyone involved in this project, I'd like to show you how subglacial bathymetry can have an impact on ice shelf stability. We have investigated the ice shelves of Dronning Maud Land in East Antarctica, and just to give you a small insight on why we're doing this and what we want to achieve. As you all may know, the floating ice shelves of Antarctica address an enormous amount of the grounded ice sheets, and a mass loss of an ice shelf is consequentially followed by an increased drainage of the corresponding ice sheet. Mass loss processes in Dronning Maud Land are currently dominated by calving and basal melting, and one of the leading requirements for correctly estimating these basal melt rates is knowing the bathymetry beneath these ice shelves. So sparse depth references exist, but the more accurate the underlying bathymetry, the higher the accuracy of basal melt estimations. What one can see here is an overview of the ice shelves within our model area. This area spans from about 15 degrees west to about 35 degrees east. And it includes the Ekström, Jelbert, Fimbul, and the King Bourdon ice shelves. And the area of these ice shelves inhabit about 20% of East Antarctica's total ice shelf area. And they also address an ice sheet area with a sea level equivalency of 1.9 meters. The bathymetric models are based on inverted airborne gravity data linked to prevalent depth references. If you're more interested in the applied methods, please pause the video here or feel free to contact me. Just looking at the bathymetric models of Western Dronning Maud Land, we can already see a couple of trends and general bathymetric features that all ice shelves in Dronning Maud Land have in common. So regarding the topography, we can observe deep troughs that extend parallel to the main ice flow direction and which are interbedded by small bathymetric highs in between, which can be seen here and here. And also we can observe bathymetric sills close to the current continental shelf and the current calving fronts. And these sills are only interrupted by a series of distinct narrow gateways. We can see the same thing for the ice shelves in Eastern Dronning Maud Land for the Nivelle ice shelf here on the left, and the Borchgrevink and Bourdon ice shelves here on the right side. Again, the bathymetric sills close to the continental shelf and the deep troughs beneath the ice shelves. Of course, these similar features and their continuity throughout Dronning Maud Land kind of speak for a similar origin story and common glacier extents. So the sills close to the present-day calving fronts, for example, imply end moraine formation by ice sheets that might have advanced up to the continental shelf edges during the last glacial maximum. And the shallow gateways within these sills are currently the limiting factor of warm deep water intrusion into these cavities. So with a similar average thermocline depth and gateway depth, only small amounts of warm deep water currently creep into these cavities. So one could say that these sills currently protect the ice shelf bases from basal melting by warm deep water ingress. And one could say that at this point, the basal melt is most likely dominated by the intrusion of solar heated Antarctic surface waters. Of course, a shallowing thermocline depth with an increased entry of warm deep water into the cavities poses a significant risk to these ice shelves in the future. Yeah, that's pretty much it so far. Thanks a lot for listening. The references are here if you want to take a look. and also a small excursus on the error estimation of the bathymetric model.